Morning, good morning, dear students. Today we are going to discuss the next topic, treatment. Yesterday we have finished and we have seen the construction and efficiency of slow sand filters. Today we'll discuss one more time briefly about the topic what we discussed in the previous class along with the today's session. Before that, we are in treatment of water. We have finished 2 stages of treatment. The name of sedimentation, followed by sedimentation with coagulation, where we have seen the removal of weighted particles and also removal of fine colloidal particles with the help of coagulates. Now we are in filtration, and here we are removing the impurities like bacteria, algae, and undesirable odor, and any other minerals which are in or else which are crossed in their permissible levels. See, have a look here. This is an outlook of treatment plant, part of treatment plant. See here, when we are going to construct treatment plants anywhere, we have seen the specifications. What are those? All the units must be constructed in a sequential order. As per the procedure. And also, there should be a proper planning, and the water must enter into the next unit based on the gravity. The elevation must be in such a way water will enter into the next zone based on the gravity, not by pumping. We have seen staff quarters must be there, and clean atmosphere has to be maintained in and around the treatment plants. We have seen. Now we are there in slow sand filters. So already we discussed this is not slow sand filter, sedimentation tank. Hope you remember, no? See, from here in this method, water will be distributed radially. Okay, radially, and the weighted particles settle at the bottom. This is about sedimentation. Next topic is here, slow sand filters. We have seen. See here what happening here. Slowly through water, the impurities may enter into the chamber. Of course, the water will enter into the unit through inlet. See here, this is the water level. Fine sand, coarse sand, gravel or pebbles. And it is an under drain. The water which is filtering by passing all these zones entered into the outlet chamber. I said that the water level in the inlet chamber and the water level in the outlet chamber gives the information about the loss of head. If this loss of head is increasing, That means the water enters into the outlet chamber, or as the flow of water that enters into the outlet chamber has been reduced, which means the clogging of filtered material. In that case, the fine, 2 to 3 centimeters of top layer of the sand has to be removed by using mechanical scrapers, and again that gap will be filled up with fresh sand or new sand, or else after washing the same sand can be utilized. This is what about the slow sand filters. So of course, yesterday we have seen. See here, construction of slow sand filters. Most generally, they used to construct in the area of up to 200 meters square per filter with an average depth of 2.5 meters to 4 meters. The top of the bed is filled up with sand in the size of 60 to 90 centimeters, which is supported on 30 to 60 centimeter thick gravel bed. First point. The effective size of filter media is generally 3 to 4 layers. Sand, coarse sand, gravel. Again, in the gravel, that is also sequential order. Okay, what means fine gravel, coarse, and pebbles. In that gravel, and fine gravel, coarse gravel, and pebbles. Likewise, we have seen construction of filter bed. That whole structure is supported on a concrete layer, which is sloping towards central longitudinal drain, connected by a open jointed system under the drain. See here, the water will be distributed uniformly over the sand bed without causing any disturbance. And here the efficiency is 100 to 200 liters per meter square per hour. What you must write when you got an exam, first of all, you must learn about this diagram, and you must know, or else you should start the slow sand filters. Else the working of slow sand filters can be explained in the following step. First one is construction of slow sand filters. In that, the layer specifications and the area that is required, 200 meters square per filter with an average of 2.52 meters to 4 meters. The diagram and all entire this description has to be mentioned when you got a question. See, the process of filtration is continued till the variation between the level of water and filter media and the level of water in the outlet chamber, which means the definition of loss of head. If the loss of head is increasing, that means the flow rate of water enters into the outlet chamber becomes reduced. It gives the clear information, reduced in the sense it gives the clear information about the change of sand bed. Else the voids are clogged. In such cases, 2 to 3 centimeters of sand on the top of the sand, fine sand, or as top of the filter bed has to be scraped out with mechanical, has to be taken off by using mechanical scrapers, and that should be washed and dried. Again, the removed, in the place of removed sand, again, the new sand will be placed, else the same washed and dried sand can be replaced. This is what about the slow sand filters and efficiency. In this method, only 98 to 99% of bacteria can be removed. Further, when we are as we are supplying to the public, disinfection is required to remove complete percentage of bacteria. Color, only 20 to 25% of color can be removed in this method, and it is not suitable when the turbidity of water is more than 60 ppm. That's what we have seen. No, now we are entering into the rapid sand filters. Now we are entering into the rapid sand filters. Rapid sand filters, see, the whole process is carried out. The whole process is carried out in an open rectangular tank with a depth of 2.5 meters to 3.5 meters in an area of 10 meters square to 80 meters square. Understand? So open rectangular tank with a depth of 2.5 meters to 3.5 meters in an area of 10 meters square to 80 meters square. The bottom layer is made up by gravel about 40 mm with the smallest of, in that the smallest size of gravel is 3 mm size, and the whole process and the whole structure is constructed layers. Each layer may exist up to 10 to 15 centimeters and 60 to 10 to 15 centimeters to 60 to 90 centimeters of total thickness. The top layer of sand with a size of 0.35 mm to 0.55 mm mm is supported on gravel bed. One more time, have a look and listen carefully. The bottom layer is made up of gravel by about 40 mm. In that, the small size gravel size, the smallest gravel particle size is 3 mm size. The whole gravel bed is constructed with a thickness of 10 to 15 centimeters to 60 to 90 centimeters and multiple layers. As in multiple layers. The top layer of sand within size of 0.35 mm to 0.55 mm is supported on gravel bed. The main function of gravel bed is to distribute the water uniformly over the sand bed, and it is also acts as barrier for inhibition of sand, which may go to the pipelines, and pipelines will be disturbed. Understand? This is the basic specification. It is to conduct in open rectangular tanks within a depth of 2.5 meters to 3.5 meters in an area of 10 meters square to 80 meters square. Understand? Simply, and in the second point we are looking and we are discussed about how we can construct. For top layer is sand whose granule size is 0.35 mm to 0.5 mm, followed by gravel bed with a thickness of granules 40 mm to 3 mm size. Smallest is 3 mm size, and whole gravel bed is made up of with layers, and each layer is made up of 10 to 15 centimeter to 60 to 90 centimeters of total thickness. The main function of this gravel bed is to distribute water uniformly, and this gravel is not allowed sand, which may enters into the underlying pipelines. This is about the structure. And have a look over here. See here, through inlet channel. This is the wall to control the flow. This is the wall to control the flow. See, through inlet, water enters and will be distributed uniformly. This is filter bed, fine sand, coarse sand, pebbles, that means gravels, multiple layers. Understand? Through this pipeline, water will be distributed uniformly on the sand bed. Slowly, the water through the voids of sand moves downwards. Moves where? Moves downwards, and it is the pipe. See, this is the pipe. See, this is the pipe outlet. See, this is the pipe. This pipe will collect the water. Pipe will collect the water, and it is the outlet. Understand? Right. See here, in the first case, when the voids are blocked, we are just removing 2 to 3 centimeters of sand from the top of the sand bed. Here, nothing, we are not doing anything. When the outlet is and the filter water ratio is reduced, simply have a look in this arrangement, compressed air tube or as pipe. Through this, the compressed air will be blown out by keeping some amount of water on the bed. The compressed air will be blown out. By blowing compressed air, the blockages in between the voids, or as the blockages in the voids will be released. Why? Because we are blowing air, we are sending compressed air. Because of the air, the voids will be opened, and the material that is filled in voids will be mixed with water, and that will be taken off. In the next step, we'll see how we can take it off. First of all, process through the inlet, water enters into the sand filter media, and this inlet is controlled or is regulated by a wall, and the water will be distributed uniformly on the sand bed. Slowly, the water through the sand bed enters into the underdrained, see, filtered water collecting GI pipe is here. It collects the water, and through this pipe, the water will be distributed for the required needs. This is a compressed air sending unit, and the water wall. See here, Through here, water enters and distributed on the sand bed, and it is the wall controlling wastewater wall. And here also one more wall controlling. See why we need this. We'll discuss in next diagram itself. Understand? This is the gangway for maintenance works. Have a look over here, and this is the cross section of rapid sand filter. You must learn about this rapid sand filter. You must learn about this diagram. Understand? See here, the structure gets support from the central sloped bottom concrete bed that consists longitudinal drain into which laterals are see the whole structure is supported on a concrete bed, central sloped concrete bed, and the main objective of this water is main objective of this particular bed is to just give the good and efficient treatment of water. See here, simple, nothing is there here. Rapid sand filters. First of all, you must write what is the required area of required area for rapid sand filters. What is the rapid? See here, 2.5 meters to 3.5 meters. 10 meters square to 80 meters square area. Bottom layer is made up of gravel. What is the size? The highest size granule is 40 mm. The smallest is 3 mm size, and the whole gravel bed is made up of with layers, different layers, and each layer constitutes about 10 to 15 centimeters up to 60 to 90 centimeters of total thickness. The top of the sand bed is constitutes the sand granules whose size is 0.35 mm to 0.5 mm is supported on a gravel bed. The main function, what is the function of this gravel bed? To support or else to distribute water equally and uniformly, and also the gravel won't allow the passage of sand through those through it, which may if sand goes, if sand enters into the underlying pipelines may be defected, pipelines may get defect. That is the reason gravel bed is acting for two purposes. One is for distributing water uniformly, and also it won't allow the entry of sand which may disturb the underground pipelines. See here, this is the structure you must remember. See, in slow sand filters, you must by heart, or else you must learn about this diagram. Simply, when you are writing this, when you are drawing these diagrams, you can write the concept. Almost from the beginning onwards, so I used to speak to you about these diagrams. You must learn these diagrams, and almost most of the topics in E1 is with support of diagrams only. This is about the slow sand filter, and it is about the cross-sectional area of or else cross-section of rapid sand filters. You must learn. See, I said that here, why these arrangements, why these valves arrangement for us. We will learn in the this is not over here. Of course, the association topic is there. How we can send this compressed air. I said that by keeping certain amount of water, we will send the compressed air, we'll blow the compressed air into the sand bed. By doing so, the voids in between the sand granules will be removed, and the dust particles in the voids will associate with water, and the clean water, or else that particular what I can say is the water which contains the blocked voids, material that is blocked in the voids can be removed, or can be taken off through outlets. That will be explained in this diagram by name backwash of filter. Understand what I'm speaking in the above sentences. When the air is blowing, the voids will be released. The material that is stuck in the voids is mixed with water, and that particular contaminated water will be taken off through outlet, and the whole mechanism will be explained with this diagram by name backwash of filter. See here, in the previous case, we have seen 2 to 3 centimeters of the sand bed. 2 to 3 centimeters of sand on the top of the sand bed will be removed, and that will be washed and that will be dried. And before we are continuing to the filter, as before we are continuing the process. But whereas here no such type of removal of, or else taking a removal of sand from the top of the sand bed and drying, washing, not here. The whole process and whole mechanism not exist in this rapid sand filters. Simply we are blowing water, the voids will be released, and with the water that is left over on the sand bed, the water which we kept on the top of the sand bed associated with the material that is released, the material release of, I mean, material which comes because of the releasing of voids, and the same water will be taken off from the chamber, and the entire process will be explained with this black wash of filter. Understand? Hope you understood about this working phenomena of um, rapid sand filters. Now we'll discuss about ABCD of this backwash filter, and we'll discuss in detail about this backwash of filter, which is a part of rapid sand filter in next class. If you have any doubts, please contact me in the domain, whatever feel convenient, either mail, message, or phone call.